Hello, this is Jack Jackson, and in this video we're going to talk about the derivatives of sums of power function. And we can combine the rules that we've learned so far to easily find the derivative of any sum of power functions, and that includes ones with coefficients. Notice that once the expression is written as a sum of power functions, we can use a combination of the sum rule, the constant multiple rule, the power rule, and the constant function rule to evaluate the derivative. Even though we are actually applying all these rules, it's actually so easy to perform the operation that we can do the entire computation in our heads. For each term, simply multiply the original power by the coefficient and subtract 1 from the power, and the derivative is the sum of these terms. This example is shown with all the details written out. The next example uses a further shortcut, doing all the computations mentally. So here we have a derivative of the sum. The last thing is adding things together, so we use the sum rule. The derivative of the first term plus the derivative of the second plus the derivative of the third. Here we use the constant multiple rule on the first two to say this is 3 times the derivative of x to the fifth. This is 5 times the derivative of x squared. On the last term, the derivative of a constant is 0 using the constant rule. And here we use the power rules. This is 5x to the fourth for that derivative, and that's 2x to the first for that one. 3 times 5 is 15, x to the fourth, and then we got 10x to the first. Now, as I said, you can actually do the whole thing in your head very easily. You just say 5 times 3 is 15, subtract 1 from the power, that's 4, plus 2 times 5 is 10, subtract 1 from the power, that's 1. And derivative of the 2 is 0. Here's an example where I did it in my head here. 3 times 7 is 21, 3 minus 1 is 2 for the power. 2 times negative 4 is negative 8, and the power goes down to the first power. Derivative of a linear term, 3x, is just 3, and the derivative of the constant is 0. So see if you can do that in this example, this exercise here. Do it on your own and come back when you're ready. Press pause if you need to. Here's another one to try. We'll go over both of these in a second. Okay, here are the answers to those. What are the examples? What are the answers to those? Yeah, let's see here. This one would be 9x to the 8th minus 28x cubed plus 6x plus 2. This would be 55x to the 4th minus 12x cubed plus 5. Now, here's another one. Oh, wait a minute. This looks a whole lot harder. Well, it's not a whole lot harder. It looks nastier, but really it's still just a sum of power functions. The trick is you do have to remember some of the properties of exponents. So the square root of x can be rewritten as x to the 1/2 power. 1 over x can be rewritten as x to the negative 1. And negative 3 over the 5th root of x can be rewritten as negative 3x to the negative 1/5. So remember those properties of exponents. So you may need to practice that a little bit. But now once we have it in this form, it's not too hard to do, the derivative. 5 times 7 is 35. 5 minus 1 is 4 for the power. 1/2 times negative 4 is negative 2 for the coefficient. 1/2 minus 1 is negative 1/2 for the power. Negative 1 times 1 is negative 1 for the coefficient. Negative 1 minus 1 is negative 2 for the power. Negative 1/5 times negative 3 is positive 3/5. Negative 1/5 minus 1 is negative 6/5 for the power. If we had started with this second line, we would just leave it like this for the end. But since they started with radicals and positive exponents, we're going to change things around. So we'll leave the first term like it is, but negative 2 times x to the negative 1/2 is negative 2 over x to the 1/2. X to the 1/2 is the square root of x. Negative x to the negative 2 is minus 1 over x squared. This is 3/5. That's 3 in the numerator, 5 in the denominator. The x to the 6/5 goes to the bottom. X to the 6/5 in mixed number form is 1 and 1/5. So there's your x here, and then that's the 1, and the 1/5 is the 5th root of x. Okay, here's one. Let's see if you can do it. You might want to press pause and come back when you're finished. Try this one on your own. Press pause now. Okay. So let's see if we can figure out what that one is. Okay. Let's see, do I have the answers down? Yeah, I've got the answers down here. Here's the answer to this one. There's the two that we did earlier. This is x to the 3/4. That's x to the -1. This is x to the -2/5. Now we just use our power rule. 5 times 7 is 35. Subtract 1 is 4. 3/4 times 3 is 9/4. 3/4 minus 1 is -1/4. -1 times -5 is +5. -1 minus 1 is -2. -2/5 times 7 is -14/5. -2/5 minus 1 is -7/5. So you have to be able to comfortable taking a fraction and subtracting 1, get a common denominator. You also have to be comfortable changing from exponent to radical form. Now we're going to change it back just to make it look more like the original. X to the -1/4 is 1 over the 4th root of x. So this becomes this right here. And then this is x to the x squared down the denominator. This is x to the 7/5 in the denominator, which is 1 2/5. There's your 1, there's your 2/5 power there. And then we have one more example that I wanted you to do. What's the derivative of 5x minus 4 squared? See if you can work that one out. Press pause and come back. Well, this doesn't actually work exactly like a sum of power functions or a polynomial, but if we square it out, it does. So using what we know now, we can square this out using our special product form or FOIL distributive property. We get 25x squared plus 16 for the n, multiply and double for the middle term, so that's -40x for the middle. Now it's pretty easy. 2 times 25 is 50, goes down the first power, and the derivative of this part is -40, the derivative of the last part is 0. So you get 50x minus 40. The original was factored, so let's go ahead and factor a 10 out of this and get 10 times 5x minus 4.